Hello and welcome to my video on detecting and caching faces using the EXIF library. I use the EXIF metadata in image files to store information on where the faces are. EXIF is often used to store information like when the photo was taken, what camera was used to take the picture, the relevant picture tags, etc. I find that a lot of people these days don't use EXIF for this purpose. So I've taken advantage of this field to cache faces and other computer vision related information for faster retrieval in the future. Sure, you can store this information in a text file as well, but what if new faces get added and deleted? I'll show some sample Python code for you to follow along next. If you haven't downloaded and installed EasyImage, please see the link in the video description. So here I'm going to show you and demonstrate how to cache faces using the EasyImage library. So here I have a Jupyter notebook open, and let's start by importing a few items that will help with the plotting. Next, let's import a few libraries that we need to use. I'm just gonna basically copy and paste these from another sheet, but feel free to type them out if that's what you wish. And you see here it's loading Keras, which uses a TensorFlow backend on my computer, but even if you don't have Keras installed, this should still work. And I have instructions on how to install this library in my GitHub repo in the links in the video description below. So next, we want to copy the test images that we're going to use. Those are included in the repo for EasyImage. Next, let's load all of our images into a variable called test images, and also print how many images we've got. So you can see we have 46 images in this test set. Next, we want to remove the EXIF tags from all the images. Next, let's show a sample image from this set of images. Alright, now here we've come to the fun part. We're gonna try to detect faces in all 46 images here. Now, we're not gonna see 46 faces because some images have no faces, or the algorithm isn't successful at detecting the face in the image, and some images have more than one face. So here we go. And it took about 4.4 seconds on my computer. Next, let's show a particular face that was detected. And you see that's the image above. And we can also get the parent image using the parent image member variable from this face5 object. Now, let's draw those bounding boxes, those green bounding boxes around the face. As you can see here, we have a box around the detected face. And if you go above, this is the same face that was detected earlier by the facial detection algorithms that EXIF calls. And just to make sure this is happening in place, we're now modifying the image to include that green bounding box. Let's plot the original image again. And how many faces do we have again? Let's see that number. And we have 48 faces. Okay, let me show you another sample face from this data set. And I'm just going to skip the steps and just go straight to drawing the green bounding boxes. And here's another face. Okay, now let me show you what happens if you call the detect faces method on test images again. And this time we're gonna basically put the faces in a new variable called faces2 instead of faces this time. And you can see it took about 0.1 seconds to detect all the faces because they've been stored in the EXIF headers of each image file. And are all the faces the same? Well, let's look at face number 5 again. And you can see that was the same face. See face 24 again. Same face. And let's look at face 43. Same face. So you can see here, this method helps you redetect faces rapidly, so you don't have to run the facial detection algorithm over and over again. Now, detecting 40-something faces in 4 seconds is basically taking about 0.1 seconds per face. And that's not a lot of time. But if you're going to do this hundreds or thousands of times, you can see this will really save you time. So I hope you enjoyed this video, and I'm going to show you more videos that demonstrate how you use the EXIF library. If you'd like to download and install it, please go to the video description below to my GitHub profile, and you can download and play around with this library. Thank you.